In the vast, silent expanse of the cosmos, where time stretches beyond comprehension and space unfurls in infinite mystery, the Earth, our pale blue dot, began its story not with a thunderous declaration, but with a whisper of dust and gas, a delicate dance of particles in the void. Some 4.6 billion years ago, in a corner of the universe that was little more than a formless haze, a cosmic cloud or nebula hung suspended, its contents a chaotic swirl of hydrogen, helium, and traces of heavier elements forged in the hearts of long-dead stars. This was no ordinary cloud, no fleeting wisp of matter destined to dissolve into the dark. It was a cradle, a primordial womb, pregnant with the potential for worlds. The Nebular Hypothesis, a theory as elegant as it is profound, weaves a narrative of how this cloud, through the subtle interplay of gravity, motion, and time, gave birth to the sun, the planets, and the Earth itself. A story that binds our small world to the grand tapestry of the universe. Imagine, if you will, this nebula as a vast, rotating veil, its particles drifting in a lazy cosmic waltz. It was not a place of order. Not yet. The cloud was diffuse, sprawling across light years, its edges fraying into the blackness of space. Within it, grains of dust, some no larger than a speck of ash, collided gently, their encounters governed by chance. Yet, even in this seeming chaos, there was a latent force at work, an invisible hand that would sculpt the formless into form. Gravity, the quiet architect of the cosmos, began to stir. Perhaps it was a shockwave from a nearby supernova, a cataclysmic explosion of a dying star that nudged the nebula into action. Or perhaps it was simply the slow, inevitable pull of matter toward itself. Whatever the spark, the cloud began to contract, its rotation accelerating as it shrank, much like a figure skater pulling in her arms to spin faster. This was the first act of creation, the moment when the nebula's diffuse sprawl began to surrender to the promise of structure. As the cloud collapsed, its center grew denser, hotter, a glowing ember in the heart of the nebula. Particles pressed closer, their collisions generating heat, their energy feeding a growing maelstrom. This was the birth of the protosun, a nascent star, not yet ablaze but pulsing with potential. Around it, the remaining gas and dust flattened into a spinning disk, a cosmic carousel of matter caught in the delicate balance of gravity and centrifugal force. Within this protoplanetary disk, the seeds of planets began to take root. Dust grains, once solitary wanderers, now clung together, forming clumps, then pebbles, then boulders. These were the planetesimals, the building blocks of worlds, each collision, a small act of creation, a step toward something greater. The disk was alive with motion, a turbulent sea of particles swirling around the young sun, their paths dictated by the relentless pull of gravity and the momentum of their dance. The Earth, though not yet a planet, was beginning to take shape within this disk, its story woven into the larger saga of the nebula's transformation. Far from the protosun, where temperatures were cooler, volatile compounds like water and methane could condense into ices, mingling with dust to form the cores of future gas giants. Closer in, where heat scorched the disk, only rocky materials, silicates and metals, could withstand the inferno. It was here, in this inner sanctum of the disk, that the Earth's earliest ancestors emerged. Planetesimals collided and merged, their impacts violent yet generative, each crash forging larger bodies. These were the protoplanets, embryonic worlds vying for dominance in a crowded, chaotic nursery. The process was neither swift nor gentle. It was a crucible of destruction and creation, where only the most resilient would endure. The protoplanetary disk, a swirling maelstrom of gas and dust encircling the nascent sun, was a forge of relentless creation, where the seeds of Earth were hammered into existence through eons of cosmic violence. In this turbulent nursery, protoplanets, hulking aggregates of rock and metal, careened through the disk, their paths erratic, their collisions cataclysmic. Each impact was a crucible, melting and reshaping the growing bodies, fusing their materials into ever larger masses. The Earth, still a molten embryo, was one of many contenders in this chaotic ballet, its form sculpted by the relentless churn of gravity and chance. The disk was no serene cradle. It was a battleground where only the most massive, the most fortunate, would coalesce into planets. Smaller bodies were devoured or flung into the void, their stories snuffed out in the dark. Yet, amidst this turmoil, the Earth endured, its mass swelling as it swept up planetesimals and debris, each addition a testament to its growing dominance in the inner disk. As the Earth grew, so too did the Sun, its core compressing under the weight of collapsing gas until, in a blaze of nuclear fire, it ignited as a true star. The newborn sun's radiance bathed the disk, its heat and stellar winds sweeping away the lightest gases, stripping the inner regions of their volatile veil. What remained was a gritty residue of silicates and metals, the raw materials of rocky worlds. The Earth, orbiting in this scorched zone, was forged in fire, its surface a roiling sea of molten rock, its atmosphere, if it could be called that, a thin, scalding haze of vaporized minerals. The protoplanet was not alone. Other bodies vied for space, their orbits unstable, their futures uncertain. Some would merge with the Earth, adding to its bulk. Others would be cast out or shattered in collisions. This was a time of upheaval, when the architecture of the solar system was still being written, its final form a distant promise. The Earth's growth was not merely a matter of accretion, but a saga of transformation. Its molten surface, churned by the heat of impacts and radioactive decay, began to differentiate. Heavier elements, iron and nickel, sank toward the core, while lighter silicates rose to form a primitive mantle. This was the planet's first act of self-organization, a step toward the layered structure that would one day sustain life. Yet, the Earth was still a world in flux, its surface scarred by relentless bombardment. Among the most dramatic of these events was a hypothesized collision with a Mars-sized protoplanet, a cataclysm so immense it reshaped the Earth's destiny. The impact, a glancing blow of unimaginable force, ejected a spray of molten debris into orbit, a glowing ring of material that would coalesce into the Moon. This violent birth bound the Earth and its satellite in an eternal dance, their fates intertwined as the solar system settled into its infancy. The disk, once a dense and chaotic swirl, began to thin as the sun's winds cleared away the remaining gas and dust. The era of planet formation was drawing to a close, leaving behind a scattering of newly minted worlds, each bearing the scars of its turbulent origins. The Earth, now a recognizable planet, was a fiery orb, its surface cooling slowly as the barrage of impacts waned. Its atmosphere, born from volcanic outgassing and the delivery of volatile-rich comets, was a choking mix of carbon dioxide, nitrogen, and water vapor, nothing like the breathable air of today. The planet was still a stranger to life, its oceans yet to form, its continents unborn, but within its rocky heart, the seeds of possibility were sown. The Nebular Hypothesis, in tracing this journey from cosmic cloud to nascent planet, reveals not just the Earth's origins but its place in a universe where chaos and order dance in endless cycles, forging worlds from the ashes of stars. The Earth, newly forged in the fading glow of the protoplanetary disk, stood as a testament to the universe's capacity to weave order from chaos, yet it was still a world unrefined, a molten sphere adrift in the nascent solar system. Its surface, scarred by the fading echoes of cosmic collisions, began to cool, the once roiling seas of magma hardening into a brittle crust. Water, delivered by volatile-rich comets and outgassed from the planet's interior, condensed in the cooling atmosphere, falling as torrential rains that carved the first fleeting rivers and pooled into primordial oceans. These were not the tranquil seas of today, but turbulent, steaming cauldrons, their surfaces lashed by ultraviolet radiation from a young, untamed sun. The atmosphere, thick with carbon dioxide and methane, trapped heat, cloaking the planet in a greenhouse shroud that kept it warm despite its distance from the sun. This was the Earth's adolescence, a time of transformation, when the raw materials of a cosmic cloud began to take on the contours of a world capable of nurturing life. The Moon, born from the Earth's violent encounter with a rogue protoplanet, loomed large in the sky, its gravitational tug stabilizing the planet's axial tilt and stirring tides in the newborn oceans. This celestial partnership was no mere coincidence. It was a cornerstone of the Earth's evolving identity, shaping its days and seasons in ways that would one day cradle ecosystems. Beneath the surface, the planet's interior churned, its molten core generating a magnetic field that shielded the atmosphere from the sun's relentless solar winds. This invisible barrier was a quiet guardian, preserving the delicate balance of gases that would eventually sustain life. The Earth was no longer just a rocky orb. It was a dynamic system, its geology, atmosphere, and orbit intertwined in a delicate dance that set it apart from its barren siblings, Mars and Venus. Yet, the Earth's story, as told by the Nebular Hypothesis, is not merely one of physical formation but of cosmic continuity. The elements that formed its crust, its oceans, and even the first flickers of life were not born in the nebula but in the hearts of ancient stars, their ashes scattered across the galaxy to seed new worlds. Carbon, oxygen, iron, the building blocks of our planet and ourselves, were forged in stellar furnaces, carried on interstellar winds to find a home in the nebula that birthed the solar system. This realization binds the Earth to the cosmos in a profound way, reminding us that our world is not an isolated miracle, but a chapter in an ongoing saga of creation, one that stretches back to the universe's earliest moments. The Nebular Hypothesis, in its elegant simplicity, offers a vision of a universe where every planet, every star, is a thread in a vast, interconnected tapestry. As the solar system settled into its modern form, the Earth continued to evolve, its oceans deepening, its crust fracturing into tectonic plates that would one day shape continents. The first tentative steps toward life, simple molecules assembling in the warm, chemical-rich waters, were still millions of years away, but the stage was set. The planet, born from a collapsing cloud of gas and dust, had become a crucible of possibility, its fiery origins giving way to a world of water, rock, and air. The Nebular Hypothesis does not end with the Earth's formation. It invites us to see our planet as a fleeting moment in an eternal process, a world sculpted by the same forces that light the stars. To stand on this Earth, to breathe its air and walk its surface, is to touch the residue of a cosmic cloud, to feel the pulse of a universe that, 4.6 billion years ago, dreamed a planet into being.